Okay, hello my pretties. We are going to get going on our chapter 1 study guide for geometry. So this section we're going to talk about 1.1, which is points, lines, and planes. 1.2, which is the segment and angle addition postulates. 1.3, the distance and midpoint formula. 1.4, the types of angles. And then 1.7, the algebraic proofs. So you're going to see all of that on your test. As we go through our study guide, might I suggest that you grab 2 different color highlighters out because it's going to help you tremendously as you kind of work through. So let's get ourselves started. Number 1 says, find the coordinates of the midpoint of segment AB if A is located at -3, 7 and B is located at 5, 6. So to find the midpoint, all we're doing is we're taking the average of the x values, the averages of the y values. That's all we have to do. So we'll take our x values, we'll add them together, divide by 2. We'll take our y values, add them together, divide by 2. So in this picture here, in my 2 points, my x value is -3 and 5, and my y values are 7 and 6. So let's start with our x values here. Going to add together -3 plus 5 and then divide by 2. And then my y values are going to be 7 plus 6 divided by 2. So you want to make sure that you do the numerator first, everything on the top, and then divide by 2 when you are done. So -3 plus 5 is 2. And then 2 divided by 2 is going to give me 1. 7 plus 6 is 13. And then 13 divided by 2, you can leave it as a fraction, or it's 6.5. And you are allowed to have decimals when it comes to midpoint. So this would mean you would go to the right 1 unit, and then you would go up 6.5 units. That is your midpoint. Number 2. M is the midpoint on RS. S is located at -6, 5, and M is located at 215. Find the coordinates for R. So this time it's a little bit different because instead of me asking you to find the midpoint, I'm giving you the midpoint and I'm asking you to find an endpoint. So I'm going to start by drawing a picture because I'm a very visual person. So segment RS means you start at R, you end at S. Midpoint is somewhere, obviously, in the middle. So these 2 pieces are congruent. So I'm going to put a little tick mark to show they're congruent. S is located at -6, 5. And then M is located at 215. And I want to figure out, okay, what are the X and the Y coordinates when it comes to point R? So all I have to do is figure out essentially what's the pattern to get from point S to point M, and then whatever the pattern is here, well, I better have the exact same pattern over here because they are congruent pieces, right? M is the midpoint. So if I take a look at just the X values, if I'm moving on a number line from -6 to +2, right? So think about walking on a number line. I have to move 6 units to get to 0 and then another 2. So that's in total, I have to move 8 units, positive units. Well, if I moved 8 positive units with the X over here, I better do the exact same thing to get my X coordinate here. So I better add 8. So 2 plus 8 gives me 10. There's your X coordinate. So for R, your X coordinate is 10. Now I'm going to do the exact same thing with my Y values. I've got 5 over here, and I'm moving to +15. So to get from 5 to 15, I add 10. And then I better do the exact same thing over here. So 15 plus 10 gives me 25. So point R is located at +10, +25. Notice how drawing the picture was like key there. Number 3, find the distance from X to Y if X is located at 5, 4 and Y is located at -2, 7. Round to the nearest 10th. Okay, so my distance formula is super simple. I take my X values and subtract them and square them, plus my y values, subtract them, and square them. Does not matter which one you start with as long as you keep the pattern the same. So I'm going to highlight my x values, which are the first ones. Okay, these are my x values. And I'm just going to substitute them into the equation. So I'm going to do, I'm going to go from y to x. So this is going to be my first point, and this one's going to be my second point. So I'm going to go -2 minus 5, close my parentheses, square it, do the same thing for my y values. Again, I have to go in the same order. So I'm going to do 7 minus 4, close my parentheses, and square it. So now I just got a little bit of order of operations here. I'm going to make sure that I do parentheses first. So we've got, we'll probably zoom in a little bit here. We've got -2 minus 5, which is -7, plus 7 minus 4 is 3, close my parentheses, square. Now I'm going to square each one of them because the next thing is exponents. I'm a lot of space. I'm going to come over here. So -7 squared means -7 times -7, which is a positive 49. Plus 3 squared means 3 times 3, which is 9. I add them both together and I get square root of 58. So that would be my exact answer for the distance between the 2 points is the square root of 58. But I asked you around to the nearest 10th. So all I'm going to do now is take that number and I'm going to plug it into my calculator, and that's all I have to do. So I probably should grab a calculator. That would be really helpful. Ooh, I forgot to grab one. Pause. Okay, so if you've got this Casio one, you've got 58. You just push that number in first, and my square root button's right here in the L, so I push Shift X squared. If I'm rounding to the nearest 10th, that's 1 decimal place. So 7.6. The number after is less than a 5. So my distance is 7.6, and you can put units if you want because we're talking about distance. Okay. Number 4. Taylor drew line segment EF on the coordinate plane. Determine the midpoint of EF and then determine the distance between the two. In order to do that, the first thing I need to do is just write the coordinates of each point. So point E, now remember, you go left or right first, the x-axis, and then up or down second. So you're starting at 0, 0. To get to this point E, I go to the right 4 and then up 3. So it's 4, 3. And then to get to point F over here, again, I go to the right 6, 7, that's 8, and I go up 10. So 8, 10. Okay, midpoint is I just take my x values, add them together, divide by 2. Take my y values, add them together, divide by 2. So I've got 4 plus 8, and then I'll divide that by 2. That's my x values. I'll do the same thing for my y values. 3 plus 10 divided by 2. Okay, so 8, 9, that's 12 divided by 2. And 12 divided by 2 gives me 6. And then 3 plus 10 is 13. 13 divided by 2 is a decimal. It is 6.5. So if I wanted to check, I could plot this on the graph. This means I go to the right 6 units and then I go up 6.5. You can go up 6.5 on a graph, right? So I go to the right 6, I go up 6, and then a half is right between. And look at that. It's right on my graph, right on my segment. So I know I did it right. There's my midpoint. Okay, now I'm going to do the same thing. I'm going to determine the distance between the two. So remember, I'm just taking my x coordinates and subtracting them, and then taking my y coordinates and subtracting them too. So like this, and then I'm just going to plug them in now. So again, my x coordinates are 4 and 8, so I'm going to do 4 minus 8. And my y coordinates are 3 and 10, keep the same order, 3 minus 10. It's okay if you switch the orders, but you have to switch for both of them. In the end, the negatives are going to get rid of themselves anyway, so it doesn't really matter. Okay. This is 4 minus 8 which gives me -4, plus 3 minus 10 gives me -7. Close my parentheses, square it, and then now I just do the exponents. So -4 squared means -4 times -4, that's 16. -7 squared means -7 times -7, which is 49. I add those two together, I get the square root of 65. That is my exact answer for my distance, but if I wanted to figure out to the nearest tenth, I'm going to take that number and push shift x squared, and it's about 8 point, now this number is a 0.6, so the number after is bigger than a 5, so I'm going to put 8.1, about 8.1 units. And there's my distance. Okay, so it's all about really patterns, making sure you keep your x's together and your y's together. Number 5, if EF is 2x minus 12, FG is 3x minus 15, and EG is 23, find the values of x, EF, and FG. The drawing is not to scale. So I'm going to go forth and I'm just going to plug in what I know. I know EF from here to here, this piece of the segment is 2x minus 12. I know from F to G, it's 3x minus 15, and I know the whole thing is 23. Well, this right here is pictures of segments. I know if I add together the two smaller segments, the two small pieces together, I should get the whole segment, the whole thing. So the two small pieces added together gives me the whole. That is the segment addition postulate. I'm not going to write the whole thing out. Segment addition postulate. It says if I add together EF plus FG, the two small pieces, I should get the whole thing, which is EG. So all I'm going to do is take the equation, substitute them in, and then it just becomes an algebra problem. So I've got 2x minus 12 plus 3x minus 15 equals 23. Okay, algebra problem. I'm going to start by combining like terms on the left. I can put 2x and 3x together, which is 5x. I can also put together the -12 and the -15. Be careful, that is a -27. And then I keep it equal to 23. So I've got all of my x's on the left. I'm going to get all my constants to the right. So I'm going to undo the subtraction by adding 27 to both sides. I didn't use my 5x, so I bring it down 5x. My 27's cancel. 27 plus 23 gives me 50, and then divide both sides by 5. I get x equals 10. Now that's great, but the question asks me to find the values of x, EF, and FG. So that means I need to take this number and substitute it in everywhere I see the x value. So I'm going to do EF first. This is 2 times, instead of an x, I'm going to put a 10 there, and then minus 12. So 2 times 10 is 20, and 20 minus 12 gives me 8. So EF is equal to 8. And then I'm going to do the same thing for FG. You can think about this. I can plug in for FG, or I can say, hey, the whole thing's 23 minus, I already know this piece I've used up 8 of the 23, so I'm just going to subtract them, and I get 15. You also can plug it in. 3 times 10 is 30, minus 15 gives you 15 again. So I did it right. Okay, there we go. Number 6. If T is the midpoint of SU, find the values of X and S. Hint, midpoint means the two smaller segments are congruent. So if T is right in the center, that means this piece ST has to be exactly the same as this piece TU. If they are exactly the same, I can just take the two equations and set them equal to each other. So my equation is going to be this segment here, ST, is equal to this segment here, TU. So I've got 9x equals 4x plus 25. And then, my friends, it just becomes an algebra problem. So I'm going to get all of my x's to one side. So I'm going to take this smaller x and move it over by undoing it. So I'm going to subtract 4x from both sides. So I get 5x equals 25. And then to get the x by itself, I divide both sides by 5. I get x equals 5. And that's fantastic, but it also asks me to find the value of st. So I'm going to take that 5 and I'm going to substitute it in right here for the value of x. So 9 times 5 gives me 45. And just to check my work, I can plug it in over here as well. 4 times 5 plus 25. I should get the same answer. So 4 times 5 is 20 plus 25 is 45. And I'm done. So even if I don't ask you for it, you can always plug it in and check just to make sure your problem is correct. All right, number 7, I am now no longer looking at segments very clearly. I am looking at angle measures. So first one says, if the measure of angle BOC is 27 degrees, so here is, I'm going to highlight them. Here's BOC, that's 27. And the measure of angle AOC is 47. So AOC is the whole thing. This whole thing's 47 degrees. I want to know what is the measure of angle AOB, this little piece that is left over on the inside. Well, I know the whole thing's 47. You've already used up 27 of the 47. All you have to do is subtract the two numbers. And if you subtract them, you get 20 degrees. So the measure of angle AOB is equal to 20 degrees. 20 plus 27 gives me 47. This is the angle addition postulate. Just like the segment addition postulate, except instead of being segments, it's angles, hence the name. Okay. Number 8. MO bisects angle LMN. Bisect means it takes the whole thing and it cuts it right in half into 2 equal pieces. So I'm going to show their equal pieces by drawing little arc marks on each one of those angles there to show that they're exactly the same. The measure of angle LMO is 8x minus 23. LMO. This one is 8x minus 23. And the measure of angle NMO, this one over here, is 2x plus 37. It wants me to solve for x and find the measure of angle LMN, which is the whole thing. Now, because I know these are exactly the same, because they're congruent, I can just take the two equations and set them equal to each other. So when you hear bisect, you should be thinking, take those equations and set them equal. And then now, my dears, it's your fave, it's algebra. So I'm going to get all of my x's to one side by subtracting the smaller x. Now I've got all my x's on the left. I want to get all my constants to the right, so I'm going to add the 23 to both sides. I get 6x equals, what's that, 60? And then divide both sides by 6 to get the x by itself. I get x equals 10. But now I need to take that 10 and I need to plug it in. Now, these are the same. It does not matter which one I plug it into. I'm going to go for this one because that one looks easier. So if I do 2 times 10, that's 20. And 20 plus 37 gives me 57 degrees. So this piece here is 57 degrees. Well, since these are the same, that means this piece over here is also 57 degrees. To find the whole angle, angle LMN, right? That's the whole thing, LMN. I want to add together the two smaller pieces to give me the whole thing. So I'm going to add together 57 plus 57. So my final answer is that the measure of angle LMN is equal to 114 degrees. And make sure you're putting degrees because we're talking about an angle. Okay, next one, number 9. If the measure of angle DEF, so here's DEF right here, is 122 degrees. Sorry, the degree symbol's not there. Then what are the measures of angle FEG? So let's do this one first. FEG. So I want to know, okay, what is this angle right here? Now, you should notice when I have highlighted here my two angles, notice that they are adjacent. They're next to each other. They share this side right here. And in total, I make this straight line right here, line DG. I know a straight line is 180 degrees. So these two are a linear pair. Now, knowing that there are a total of 180, I've already used up 122 of the 180. So I have to figure out what's left over. Essentially, I'm saying to myself, 122 plus what number gives me 180? Or another way you can do it is just subtract the 2. And if I subtract the 2, I get 58 degrees. So this angle right here, the measure of angle FEG is 58 degrees. Now that's just the first part. The second one asks me, what is the measure of angle HEG? Oh, I just hit my head, oops. HEG. So it's this one right here. Now, we got 2 different ways to go about this. Notice that angle FEG and angle GEH, these two also are a linear pair. They make a straight line. So what I can do is take 180 and subtract what I have, which is 58. But you're going to get the exact same thing as over here, which is 122 degrees. These two angles here that make an X and are across from each other are called vertical angles. And remember, vertical angles are congruent. This is the symbol for congruent. That means they're the same size and the same shape. So look at this. This angle here is 122. This angle here is 122. That means this angle here is 58 and this angle here is 58. So just like that, if I give you one number, you should be able to get all of them. If you add all of them together, you get 360, which is a circle. So that's another good way to check and see if your answers are correct. All right, next page, number 10. Okay, in number 10, I have given you a couple statements. I've given you a picture. And all I want you to do is fill in the reasoning for each statement. So remember, this is a proof. On the left, you have your statements. On the right, you have your reasons. So I'm giving you all the statements. You just have to tell me what's the reason for each one. So the first one says, if you add together the measure of angle PQR, that's this one, PQR. If you add that together with the angle SQR, this purple one over here, you should get the measure of angle PQS, which is the whole thing. So I want to know, hey, what says I can add the two small angles together to get the whole thing? That is the angle addition postulate. Angle addition postulate. Okay, let's keep going now. To get from letter A to letter B, I went from all these kind of like angles to suddenly having equations. I took these equations here and I substituted them in for each statement. So there's my substitution property. To get from B to C, I said, okay, let me combine together my x's and combine together my constants. That is called simplifying, or you can also write it as combine like terms. To get from C to D, so I went from 2x minus 2 equals 100 to 2x equals 102. Well, what I did was I added 2 on both sides. And that is called, since you did it on both sides, that is called the addition property of equality. You have to put property of equality because it's happening on both sides of the equation. And then the last step, of course, to get from D to E, I divided both of them by 2. That's the division property of equality. So you have finished your justifications. Number 11, complete the statement for the transitive property of congruence. So the transitive property, I always like to think of it like transitive means a train. So you're going from one thing to the next. So this sentence says, if segment XY is congruent to angle ZV, and angle ZV is congruent to angle UV, well, then that means if these two are the same and these two are the same, well, then this first one and the last one better also be exactly the same. So segment XY should be congruent to the last one, which is UV. All right, number 12. Complete the two-column proof. Again, here are your statements. And then over here, you have to write your justifications for each one. So first thing you see is this equation. Look right here. It's exactly the same thing as what's given to you. You always got to start with something that's given. Because otherwise, if I don't give you anything, there's no problem to be done. Now, to get from A to B, I went from 9x minus y equals 3 to 54 minus 4y equals 3. So the only thing that really changed here was my 9x became 54. Well, how did I do that? I took this x value and I plugged it in right over here. When you plug something in, that's called the substitution property. Okay, plugging it in. You're taking the place. Think about, right, like when Miss Damaso is gone, someone comes in and takes my place. A substitute comes in and takes my place. It's the same idea. All right, to get from B to C, I noticed that the 4y stays. The 54 moved to the other side by subtracting on both sides. So that is the subtraction. And because it's on both sides, it's the property of equality. Property of equality is on both sides. To get from C to D, pretty easy. Looks like I'm dividing both sides by -4. And so that is, again, it's on both sides. So it's the division property of equality. And then my last step is, you'll notice from D to E, the only thing that changed is I took my equation and I flipped it. They switched sides. When they switch sides, that is called the symmetric property. And there we go. We've got our sentences done. On to number 13. All right. Complete the two-column proof. So here's my given information. Notice this is exactly the same thing. So my first reason is it's given to me. To get from A to B, what I noticed is that the 5 changed to a 3. So what I ended up doing was subtracting 2 from both sides. That is the subtraction property of equality because it's on both sides of the equation. And then now here's what's a little different. I went from x divided by 3 to just the x value. And I went from 3 to 9. So really what I did was I had to take both sides and get rid of that denominator by multiplying both sides by 3. So since I multiplied on both sides, it is the multiplication property of equality. Okay, last section. Number 14, again, same idea. Identify the missing justifications. Okay, so the first thing I'm giving you is that angle AOC, this whole thing, is 152 degrees. My first part says, if you take the measure of angle AOB, that's this angle right here, and you add it together with the measure of angle BOC, that's this one right here, add those two together, you should get the whole thing, angle AOC, this whole thing. Well, that is called, when you add the two pieces of the angle together, that's the angle addition postulate. Okay, I cannot fit that whole word, so postulate. Okay, now, to get from A to B, I'm going from measures of angles to suddenly having equations. So they're taking the place, they are substituting in. This is the substitution property. To get from B to C, the only thing that looks like it's changing here is the parentheses are going away, and the parentheses are becoming 4x minus 4. So what I'm doing is I'm taking that 4 and I'm multiplying times everything in the parentheses. That is called the distributive property. And it's just a property because you're not doing it on both sides. It's just one side. Property of equality has to happen on both sides. To get from C to D, the only thing I'm noticing that changing is the x's are being combined together to get 6x. That is either called, you can write combine like terms, or you can put simplify. Both are acceptable. Okay, next one, to get from D to E, I notice that I add 4 to both sides. So that is the addition property of equality because it's happening on both sides. And then my last step is divide both sides by 6. So that is the division property of equality. Okay, last proof, then we're almost done. Okay, in number 15, you are given a full segment, and I tell you that AC, the whole thing, is 24. So my first statement says, if you add together section AB together with section BC, add those two segments together, you should get the whole thing, and that is called the segment addition postulate. Notice you definitely, when using those postulates a lot, so you definitely have to have those two memorized. Okay, to get from A to B, I go from the names of segments to equations. So what I'm doing is I'm substituting in or taking the place. So it's the substitution property. I should put P for property. To get from B to C, I've put together my like terms. I've combined the 3x and 2x to get 5x. So that's either combine like terms or simplify. To get from C to D, I'm moving this 9 to the other side by subtracting it. So that is the subtraction, and it's a property of equality because it's both sides. And then the last step, to get from D to E, I'm dividing both sides by 5. So that is the division property of equality. So the important part here is you're putting property of equality if it's happening on both sides. Okay. Last few, we're almost there. Number 16 says angle 1 and angle 2 are supplementary. So supplementary means if you add them together, they should give you a straight line, which is 180 degrees. I give you the measures, and I want you to find the measure of each one using those equations. So I'm going to take those equations and substitute them in. I'm going to take angle 1, which is x minus 27, plus angle 2, which is x plus 93, and set it equal to 180 degrees. So I'm going to combine together my like terms. X and x is 2x. Negative 27 and a positive 93 is a positive 66. And then I set it equal to 180. And then it's just a little bit of algebra. subtract 66 on both sides. I get 2x equals 114, and then divide both sides by 2, and I get x equals 57. Now I have to take that and plug it into the equation. So for the measure of angle 1, instead of an x, I'm going to substitute in my 57. So I've got 57 minus 27, which is 30 degrees, and it's degrees since it's an angle. I do the same thing for the measure of angle 2. It is x plus 93, so that's 57 plus 93, which gives me 150. And if I add those two together, I get 180, so I've done it right. Number 17, angle 1 and angle 2 are complementary. Complementary means when you add them together, they give you a right angle, which is 90. So just like the same problem as before, I'm going to add my two pieces together, but this time I'm going to set them equal to 90 degrees. So I've got 2x, probably should have done over there, plus 15 plus 5x minus 9 equals 90 degrees. Again, combine my like terms. I get 7x. And then 15 minus 9 is 6. Equals 90. I subtract 6 from both sides, and I get 7x equals 84. That's right. And then I divide both sides by 7. And I get x equals 12. Again, I have to do the same thing. I have to take my equations and plug them in. So the measure of angle 1 is 2 times 12 plus 15. So that is 24 plus 15, which is 39 degrees. And then the measure of angle 2 is 5 times 12 minus 9. And that gives me 60 minus 9, which is 51 degrees. And if I add those two together, I get 90. So I did it right. We're good. Last one. Woo. Find the value of x and y. The drawing is not to scale. So this problem is very similar to this one over here, number 9, right? Vertical angles are congruent, and two angles that are next to each other should be the same, or should be, excuse me, supplementary. So this angle and this angle are vertical angles. And I know vertical angles are congruent, which means they're the same. So I'm going to take these two and set them equal to each other. And then I'm just going to solve it like an algebra problem. Subtract 1, subtract 1. I get 6x equals 114. Divide both sides by 6. And I get x equals 19 degrees. Okay, so this is 115 degrees. If I would plug it in, I should get 115 degrees. I also know that this one here and this one across from it are also vertical angles, but I know that these two angles right next to each other are supplementary. They add up to 180 degrees. So I'm going to write a second equation now that says if I add together the 5y and the 115, I should get a straight line. So my second equation is 5y plus 115 equals 180. I don't want to work with, like, technically these two are also equal to 180, but you don't want to put 5y and 6x plus 1 together before you figured it out, because you've got a y and an x. You've got two different variables and you're not going to be able to solve it. So solve for one variable first before you try to solve for the next one. Okay, and then this is, again, just algebra. So I subtract 115 from both sides. I get 5y equals 65. And then divide both sides by 5. I get y equals 13 degrees. And then if I want, I can plug it back in. So 5 times 13 gives me, I don't know what that is, 65 degrees. And hey, that means this is 65 degrees. And I can check 115 plus 165 gives me 180. So I did it right. All right, that is it. We are done with our chapter 1 study guide. So hopefully that helped you out. If you do have questions, please come see me. But definitely make sure you know how to do all the problems on that paper, because you're going to see a lot of very similar questions on your test. A cough, cough, hint, hint, wink, wink. All right, so hopefully that helped you out. If you have any questions, let me know. Have a grand day, and good luck when you take your chapter 1 test.